A single crystal of amethyst inside a geode grows by exerting pressures up to 2,000 atmospheres. That is roughly equal to sitting beneath 2 kilometers of solid ocean water. And it does this silently, invisibly, inside a hollow rock the size of a grapefruit. Here is the part that should stop you cold. That pressure is not applied from the outside. The crystal builds it from within itself, atom by atom, as it grows. If a human cell were trapped in that environment, it would not compress. It would rupture instantaneously. The crystal does not care. It has been doing this for millions of years. So how does a fragile mineral growing inside a hollow rock generate the same force as a hydraulic industrial press? And what does that tell us about the invisible violence hiding inside every beautiful thing in nature? Let us start with what a geode actually is. Imagine a gas bubble trapped inside cooling lava, roughly 300 million years ago. Over millions of years, mineral-rich water seeps through the porous volcanic rock. It enters that bubble slowly. The water carries dissolved silica, the same basic compound as quartz. As the water chemistry shifts, temperature drops, and concentration rises, the silica stops being happy dissolved in the liquid. It wants to become solid. So it does. This is crystallization. And crystallization is not gentle. It is a phase transition, a fundamental restructuring of matter. When atoms lock into a crystal lattice, they release energy. They force neighboring atoms into alignment. They pull surrounding material toward them with extraordinary precision. And when a confined space limits how far the crystal can grow outward, it pushes. Here is the analogy that makes this click. Think of crystallization like a crowd of people suddenly deciding to form a marching formation inside a small room. Each person grabs their neighbor and locks arms. The formation wants to expand. The walls cannot move, so the pressure builds. Now imagine that process happening at the atomic scale, trillions of times per second, for thousands of years. The technical term is crystallization pressure, sometimes called disjoining pressure in confined geometries. It is the force generated when a growing crystal is constrained by surrounding rock. In laboratory conditions, halite crystals, ordinary table salt, have been measured generating pressures between 2 and 3 megapascals. Calcite pushes harder. Certain evaporite minerals can crack granite. Not metaphorically. Literally fracture rock that resisted erosion for millions of years. This mechanism is actually one of the primary ways mountain rocks get broken down over geological time. When salt or ice crystals grow inside microscopic pores in cliff faces, they wedge the rock apart from within. The Grand Canyon is partly carved by rivers, yes, but it is also slowly being unmade by crystals you cannot see. Inside a geode, this same force is what creates those incredible geometric formations. The crystal does not just grow in a random direction. It grows in the specific direction its lattice structure dictates, following invisible mathematical rules encoded in the angles between atoms. Every amethyst point you have ever seen was forced into that exact angle, 58 degrees on certain faces, by quantum mechanical constraints on how silicon and oxygen atoms bond. If this blew your mind, subscribe right now. We cover the science that textbooks skip, the part where physics gets genuinely unsettling. Here is the deeper layer. The violence of crystallization does not just scale up. It scales down in ways that are even stranger. When proteins misfold in your body, they can crystallize. Certain diseases like gout happen because uric acid crystals grow inside your joints. Those crystals exert the same kind of pressure we just described. They do not just hurt. They physically tear apart soft tissue at the cellular level. The same physics destroying mountain granite is destroying a joint from the inside. And it goes further. Kidney stones are crystals. Arterial plaques have crystalline components. Even certain brain diseases involve protein crystals forming in tissue that was never built to withstand crystallization pressure. The geode is not just a beautiful rock. It is a scaled-up, slowed-down version of a process happening inside your body right now. But here is where this gets genuinely philosophical. Every geode you have ever seen represents millions of years of atomic-scale violence producing something humans consider beautiful. We look at that purple amethyst formation and we feel awe. We do not feel the 2,000 atmospheres that built it. We do not feel the rock that was slowly fractured to create the hollow space it grew in. We only see the result. This is one of the stranger truths in physics. Extreme force at small scales, applied over vast time, produces structures that appear serene. The crystal does not know it is beautiful. It is simply matter obeying thermodynamic rules, finding the lowest energy configuration available to it given the constraints of space and chemistry. The geode is evidence of something profound. The universe does not need a goal to produce structure. It does not need intention to produce beauty. It just needs pressure, time, and the mathematical perfection baked into the laws of atomic bonding. Future research into crystallization mechanics is actively being applied to materials science, specifically in growing perfect semiconductor crystals for computing and solar panels. The same atomic precision that builds an amethyst over 300 million years can theoretically be harnessed to build computational materials with zero defects. We are essentially trying to do in a laboratory what geology does in the dark, under a mountain, with time we cannot imagine. So the next time you hold a geode, understand what you are actually holding. You are holding the record of forces that would destroy every soft tissue in your body. You are holding the frozen aftermath of atomic violence that outlasted every dinosaur, every ice age, every civilization humans have ever built. It sat there, in the dark, growing at pressures that would kill you, until someone cracked it open and found something they wanted to put on a shelf. Nature did not make it for you. You just got to be there when someone finally looked inside. If that reframes how you see the world around you, subscribe. Drop in the comments. What other everyday object do you want us to reveal is secretly running on brutal physics?